Hello, today I am going to talk about the Radix sort. If you are a computer science student, you've probably come across several common sorting algorithms already. And this one's a cool one because it's generally more efficient for large arrays where the numbers are all relatively small in comparison to the size of the array. And it's really cool how it works. I'll show you what I mean in a minute. How does Radix sort work? Well, you first have to look at the least significant digit of each number, and then you sort them based on that alone. Once you've done that, then you sort them again based on the second most significant digit, and then the third, and so on. And it actually works surprisingly well. Again, you'll see what we mean as we continue. First, consider this array I have here in front of me of 7 numbers. 9, 179, 139, 38, 10, 5, 36. How do we sort that? Using Radix sort, we'll sort it like this. Consider that we have a bunch of linked lists here in front of us. We have 10 here. Each one will represent a digit that each significant digit can be. As you can see, each digit is somewhere between 0 and 9. We know that. And what we're going to do is we are going to sort each number into one of these lists as we go along. By the way, if you don't know what a linked list or a queue is, don't worry, that won't be too important unless you're actually trying to code this. For now, just assume that it's going to be a list that attached to each of these. Now when we start, we want to find the least significant digit, which will be in the ones column. To find that in a code algorithm, we would start by having a variable m equal to 10 and n equal to 1. You'll kind of see what this means as we continue. M sort of mods the number. Mod is a term used in computer science programming to say we find the remainder of it after dividing it by that number. And n will be a variable that helps us find the number at that specific column, and you'll see what we mean as we continue. Just for now, it'll be set to 1. So as we start, the first number we have is 9. How do we put that in the list? Well, 9 mod 10, that means the remainder of 9 divided by 10, which will be 9. And 9 divided by 1 will be 9. Therefore, we have to put 9 in the 9s list. Good. Let's continue. The next number is 179. Now 179 mod 10 will be 9, and 9 divided by 1 will be 9. So we also put 179 in the 9s list. The next is 139. 139 mod 10 is 9. 9 divided by 1 is 9. We put it in the 9s list. Next we have 38. If we have 38 mod 10, we would get 8. 8 divided by 1 will be 8, so we put it in the 8s list. 10. Now 10 mod 10 will be 0, because the remainder would be 0. 0 divided by 1 will be 0, so we have to put it in the zeros list. 5. Now 5 mod 10 will be 5, and 5 divided by 1 will be 5, so we have to put it in the 5s list. Okay, we're almost done. 36. 36 mod 10 will be 6, and 6 divided by 1 will be 6. Good. So we put it in the 6th column. So we have all these lists here in front of us. What do we do with them? Now that we're at the end of the array, we have to replace the array with a new array with sorted values. What sorted values do we have? Well, we read them back into the array by looking at the very top list and putting them in the array one by one from the beginning to the end of that list. For example, the top value is 10, and that's the only one in that list, so we put 10 in first. and then we go down, we put in 5, then 36, and then 38. And then the 9th column, we have 3 numbers there, but we put them in one at a time in the order that they are already in the list. So we would add 9, then 179, and then 139. And that's our new array. Now, as you can see, this list doesn't look like it's sorted right now, but we're not done. So now, as we continue, we are going to multiply m by 10 and multiply n by 10. What this means is that we are going to start modding each number by 100, which will give us a remainder of between 99 and 0. But that's going to be a 2-digit number. We only want the second digit, not the first one. I mean, not the number in the 1's column, we want it in the 10's column. So, if we divide that number by 10, and we would get the number we want, if we convert it to an integer, of course. So let's continue. The first number we have now in the list is 10. 10 mod 100 is 10, and 10 divided by 10 is 1. So we put it in the 1's column. The next number is 5. 5 mod 10 is 5. 5 divided by 10 is, well, it's 0. So we have to put it in 0's column. 36 mod 100 is 36. 36 mod 10 will be, 36 divided by 10 will be 3. 38 mod 100 will be 38. 38 divided by 10 will be 3. 9 mod 100 will be 9. 9 divided by 10 will be 0. So we put it in the 0's column. 179. 179 mod 100 will be 79. 79 divided by 10 will be 9. Sorry, 7. That's a mistake there, my apologies. 139 is the last one we have. 139 mod 100 will be 39. 39 divided by 10 will be 9. And so we put that also in the third's column. So now we have these new lists here in front of us, again sorted in this manner. We have to put these back into the array now. And we do it in the same method as we did before. We put 5 first, 9, 10, 36, 38, 139, and 179. Good. Now, if we look at the list right now, it happens to be in order, but no, we're not done. We have to keep going until we have reached the maximum integer value, which in this case is the 100th column. So we have to sort all of these by the 100th column. To do that, we multiply m and n by 10. And we continue the same way we did before. We put in 5 first. 5 mod 100 is 1000 is 5. 5 divided by 100 is 0. And I'm not even going to explain the rest because by this point you know what we're doing. So now we have 139 and 179 left. Those will be the only ones that don't go in the zeros column. Because if you divide them by 1000, mod them by 1000 and divide them by 100, you would get 1. So let's do that. Good. Now we have to put them back in the array. How do we do that? By the same way we've done it before, by putting them in one at a time in the order that they are in right now. So we put in 5, 9, 10, 36, 38, then we put in 139 and 179. Good. Now we are done. And the sorted array we have here in front of us is complete. As you might have noticed, the mod value m and the divisor value n will go as big as the number of digits inside the array. In other words, it will increase 1 digit each time until the array is sorted, like I've explained to you. In this example, the significant digits increase each time. Now, I would hope that if you are watching this video and if you've understood it up to this point, you would know what significant digit means. But just in case, the least significant digit when you start is in the ones column, and that would be on the rightmost side of your number. And the second least significant digit, which is in the tens column, would be the next one over. And in this case, it would be in the hundreds column would be the most significant digit. Anyway, thanks for watching. That is how Radix sort works. I hope this has been useful for you, and I wish you all well in your computer science and mathematical adventures.